Imagine picking up a strange dark rock from the ground. It feels heavy. It shines in a way normal stone does not. And when you strike it, it does not break like flint or crack like bone. Thousands of years ago, this kind of discovery may have changed the future of humanity. Because before iron became plows, swords, nails, armor, wheels, tools, and machines, it was simply a mystery, a strange material hidden in rocks, and sometimes fallen from the sky. So, how did ancient humans discover iron? The story does not begin in a laboratory. It begins with curiosity, fire, accident, and patience. For most of early human history, people made tools from stone, bone, wood, and later copper and bronze. Stone was sharp and useful. Bone could be shaped. Wood was everywhere. Then humans discovered metals. Copper was one of the first. It could be found in a relatively pure form and shaped by hammering. Later, people learned to heat it, melt it, and pour it into molds. Then came bronze, made by mixing copper with tin. Bronze was stronger than copper. It made better weapons, better tools, and better ornaments. For a long time, bronze was the metal of power. But iron was different. Iron was not easy. Unlike copper, iron rarely appears on Earth's surface in a clean metallic form. Most iron is locked inside ores, mixed with oxygen and other elements. To get usable iron, ancient people needed much higher temperatures and more complicated methods. So the first iron humans used probably did not come from the ground. It came from meteorites. Meteorites are pieces of space rock that fall to Earth. Some contain iron and nickel. When ancient people found these meteorites, they were holding metal that had already been formed naturally. No mining, no furnace, no smelting, just a strange metal from the sky. This early iron was rare, precious, and mysterious. In ancient Egypt and Mesopotamia, iron objects existed before iron smelting became common. Some of these objects were likely made from meteorite iron. That is why early iron may have been treated almost like a sacred material. It was not ordinary. It was not common. It was literally sky metal. But meteorite iron was too rare to build a civilization on. If humans wanted more iron, they had to learn how to pull it from stone, and that required fire. Ancient people already knew fire could transform materials. Fire turned clay into pottery, fire cooked food, fire hardened wood, fire melted copper. So it is not hard to imagine early metalworkers experimenting with different rocks inside hot fires. They may have noticed that certain red, brown, or black stones behaved strangely when heated. These stones were iron ores. Common iron ores include hematite and magnetite. Hematite often has a reddish color. Magnetite can be dark and magnetic. To ancient eyes, these rocks may have looked unusual. Some could be used as pigments. Some were heavier than normal stones. Some reacted differently in intense heat. But iron ore does not simply melt in a campfire. Iron has a very high melting point. Early furnaces could not usually melt iron completely. Instead, ancient metalworkers developed a process called smelting. Smelting is not just heating a rock. It is a chemical transformation. In simple terms, iron ore contains iron joined with oxygen. To free the iron, people needed heat and carbon, usually from charcoal. Inside a hot furnace, charcoal helped remove oxygen from the ore. The result was not liquid iron flowing like water. Instead, early smelters produced a spongy lump of iron and slag called a bloom. This bloom had to be hammered again and again. Hammering pushed out impurities. It compacted the metal. It turned the rough bloom into workable wrought iron. This process took skill. It took practice. And it probably took many failures. Imagine an ancient worker building a small clay furnace. They add charcoal, they add crushed ore, they pump air with bellows to make the fire hotter. Smoke rises, sparks fly, hours pass. Then they break open the furnace and find a strange glowing mass inside. At first, it may have looked like waste, but when hammered, it became something new, something tough, something useful. This was one of the great discoveries of ancient technology. But it did not happen everywhere at once. The Iron Age began at different times in different regions. In Anatolia, the Near East, parts of Africa, India, China, and Europe, ironworking developed through different paths and at different speeds. There was no single moment when one person discovered iron and the whole world changed overnight. Instead, iron was discovered, tested, forgotten, improved, traded, and spread over centuries. For a long time, bronze remained more reliable. Bronze was easier to cast. It could be melted and shaped into fine objects. Skilled bronze workers already knew how to make tools and weapons from it. Iron had one major advantage. The raw material was more common. Copper and tin were not always easy to find together. Tin especially could be rare and had to be traded over long distances. Iron ore, however, was much more widely available. Once people learned how to smelt and forge it, iron could be produced in larger amounts. That changed everything. Iron tools helped farmers clear forests, cut wood, dig soil, and harvest crops. Iron plows and blades made agriculture more productive in many places. More food could support larger populations. Larger populations could support bigger towns, stronger states, and more complex economies. Iron also changed warfare. Iron weapons were not always magically better than bronze weapons at first. Early iron could be inconsistent. Some bronze weapons were still excellent. But because iron was more widely available, armies could equip more soldiers. Over time, blacksmiths improved their methods. They learned how heating, hammering, and cooling affected the metal. They discovered that adding and controlling carbon could make iron harder. This was the long road toward steel. Steel is basically iron with a controlled amount of carbon. It is stronger and more flexible than ordinary wrought iron. Ancient smiths did not understand atoms or chemistry the way we do today. But they understood results. They knew which fires worked best. They knew which ores were good. They knew how the color of heated metal revealed its temperature. They knew when to hammer, when to reheat, and when to cool. Their knowledge came from hands, eyes, sound, and experience. In that sense, the discovery of iron was not just a discovery of a material, it was the discovery of a process. Humans had to learn to see metal inside stone. They had to learn that earth could be transformed by fire. They had to build hotter furnaces. They had to control airflow. They had to separate useful metal from waste. They had to hammer weakness into strength. That is why iron changed the world. It was not because iron was easy, it was because humans learned how to master something difficult. Think about the chain of ideas. Someone notices an unusual rock. Someone puts it near fire. Someone sees a change. Someone tries again. Someone builds a hotter furnace. Someone adds charcoal. Someone hammers the result. Someone realizes this strange lump can become a blade. Then the knowledge spreads. A tool becomes a trade. A trade becomes an industry. An industry changes farms, armies, cities, and empires. This is how human progress often happens, not in one perfect moment, but through generations of observation and experiment. Iron also changed the role of the blacksmith. In many ancient societies, smiths became respected, feared, or even mythologized. They controlled fire. They transformed stone into tools. They made weapons for warriors and plows for farmers. To people watching from the outside, the forge may have seemed almost magical. A dull rock enters the fire. A shining blade comes out. But it was not magic, it was knowledge. Hard-earned knowledge. The discovery of iron reminds us that ancient humans were not primitive in the way people often imagine. They were problem solvers. They were experimenters. They watched nature closely. They tested materials. They learned from failure. And they passed that learning forward. The first iron object may have been a bead, a blade, a tool, or a sacred item made from meteorite metal. The first smelted iron may have been an accident in a furnace built for something else. We may never know the exact first moment, but we know the result. Iron helped reshape human civilization. It cut fields, built homes, forged weapons, strengthened wheels, held ships together, supported cities, and eventually became the backbone of bridges, railways, engines, and modern industry. All of that began with ancient people asking a simple question. What is this strange rock, and what happens if we put it in the fire? That question helped move humanity from stone and bronze into a new age. The story of iron is the story of curiosity becoming power. And sometimes the future begins as a heavy stone in someone's hand.